welcome to the presentation Where AI Meets Automotive. My name is Alik Gorenshtein, and I am from the Alliance Innovation Lab. Alliance is a long-term partnership between Renault, Nissan, and Mitsubishi Motors. The Alliance Innovation Lab here in Israel is aimed to bridge the gap between Israeli technological ecosystem and our corporates in France and Japan. Our main focus is on cybersecurity, sensors, data and AI. Obviously, I lead data and AI domain. So why should we use AI in the automotive? Basically, if you take a look at other sectors like e-commerce or media, we are talking about efficiency, we are talking about personalization and comfort. All exists in the automotive. I mean, we do try to improve the efficiency, we do improve the comfort. However, our mission is much bigger. About 1.3 million casualties each year. It means that till we go out from this session today, about 100 people will be dead over the globe due to the road crashes. And when we take a deeper look at those casualties, about 94% of those casualties are due to human errors. So the question is, how do we deal with it? There was massive investment in passive safety systems like seatbelts, airbags, and headrests. However, those make the damage minimized when the accident happens. We should go to a point that we actually prevent the accidents from happening. To achieve this goal, we need higher level of intelligence, since driving isn't such an easy case. So if we are talking about the need to replace a human, we sort of talk about two different approaches. One is autonomous driving, mean actually putting the robot instead of the driver, and the another one is driving assistance systems. It means that we should help the driver to drive safely. Another example of applications in the automotive is driver monitoring systems. Those are the systems that are aimed to alert the driver if he's in sleepiness or if he's in distracted condition. Anyone probably used at least one in his life. Oh, sorry. Yeah, I'm sorry. At least once in his life, he used his cell phone while driving. There are many other examples, but let's talk about connected vehicles. We are talking about the need to connect all the vehicles' data to the internet, and this way there are many services arising around this data, like preventive maintenance, AI-based insurance, mobility as a service, shared mobility, and completely new strategies of mobility. During this presentation, I'll focus on autonomous driving and driving assistance systems. I would like to introduce you Nissan's ProPilot 2 system, which is available on the market for quite a long time now. Just enjoy the movie and we'll go afterwards to talk about it. at this point, you saw a system that is currently available on the market about a couple of years in Japan. The question is, where are we in terms of fully autonomy? Society of Automotive Engineering defined it several levels of automation. So level 0 is zero automation, the driver is in charge of everything, while level 5 is full automation, means it's driverless cars. How far from fully autonomous cars are we? It's an interesting question, and if we take a look at those quotes from the last 6 months, we can understand that there is sort of very high level of pessimism in the market about the current status. So, just a word back, the car that we just saw is level 2. Automation means it can drive autonomously, but way from the full automation. So let's take on some of those quotes. I would like to focus on Sebastian Thrun. Sebastian Thrun is a person who won every possible competition in autonomous driving about 15 years ago. He was actually former vice president of Waymo, Google's self-driving company. And this is what Sebastian has to say. We'll have self-flying cars before self-driving cars. So let's try and touch this quote. Are self-flying cars, are self-flying vehicles such a new concept? And I claim that it's ain't. We have a lot of autonomous systems in the air. And this is the right time to introduce my background. I am an aerospace engineer. For the last decade, I developed and did the development of several decision support systems and autonomous systems in the defense industry. So I have a clue about systems like this. If you talk about autopilot, most of the passengers' flights are done using autopilot. Again, UAVs, drones. There are two types of drones, remote controlled or fully autonomous drones. Think about NASA space mission or Bereshit lunar mission that was conducted here in Israel. All of them are autonomous missions. Finally, about a week ago, there were hundreds of rockets and missiles fired into Israel. And again, there were autonomous interceptors launched and targeted those threats. So basically, we see that in the defense industry, there are many autonomous systems that are operational for quite a long time. We are talking about tens of years. So this is my question. What is such a big deal to develop self-driving cars if we actually have self-flying cars for such a long time? So let's take a look and compare those two industries. First of all, we need to understand that both systems are safety-critical systems. When we talk about safety-critical systems, those are the systems that should not fail. But if they fail, under no circumstances, they should cause death or serious injury. It means that we need to cover and test every possible scenario. It means to cover every possible scenario, we require enormous amount of effort. When we talk about commonalities between those two industries, so it's about harsh weather conditions and lightning conditions. And in terms of these two, it's completely the same problem. However, the main differences between those two industries are about the environment. If we think about air traffic, it's completely controlled. Air traffic controllers are there to make sure that no two aircrafts are in vicinity one to another. However, when we talk about driving environment, we are talking about dynamic, very uncertain, and worse than that, influenced by human behavior environment. And it appears that as humans, we are capable to deal with those uncertainties very well. But in order to be able to deal with those uncertainties, we need our machines to be very intelligent. Let's think about the following scenarios. Sometimes we see people standing by the crosswalk, and we are capable to understand whether they intend to cross the road or they are just standing there for fun. Also, think about a ball rolling on the road. Each and everyone understands that we should slow down in such a condition. However, we should introduce those intelligent systems when we are at stop lights, and sometimes we exchange eye contacts. How do we introduce this level of intelligence to the machines? So basically, we need to be able to teach the machines to understand the context, the prior and semantic knowledge, and to be able to calculate all the likelihoods of mobile objects in the system travel path. Then we will be able to get to the point that our vehicles are completely autonomous. Another and last point is completely different budget approach. Unlike in the defense industry, which is dominated by government or business to business, we are talking about final customer. And in the automotive industry, we check very carefully whether the customer will be ready to pay very high price for those autonomous systems. So just to summarize, I would like to think that what Sebastian really meant to say, that aerial environment is much easier than ground driving environment that the autonomous vehicles need to deal with. On the other hand, I would like to say that about 10 years ago, when the autonomous race just started, everyone was sure that in 10 years, just now we will be having autonomous cars at scale. However, today we are talking about another 10 years and maybe more. So I believe that at this point of time, we just don't see all the complexities. And let's focus our talk now on how to reach Eddy. So basically, we understand at this point that there is enormous amount of scenarios that need to be validated. To validate those scenarios, we need a lot of data. Real-life data is very expensive. For each real-life kilometer, we need about 1,000 simulational kilometers in order to get to the right level of validation. The good news is that we see more and more applications of AI to be used to help us create this enormous amount of data and to provide the different scenarios needed to complete those difficult validation cases. So think about labeling the data. Once upon a time, it was only human labeling. And again, human labeling is very costly. But now there are some sophisticated cases and DNNs that are providing us automatic labeling. Adding edge cases in real data, we should teach the systems to be able to tackle not only nominal cases, but every case. So the good news is that now that we have those AI-powered systems, we use AI in order to validate and run and make sure that everything works as expected. At the end of the day, we will have systems, AI-based systems that will manage AI systems. AutoML, auto machine learning, is where the system, the machine itself, finds the best algorithm and the appropriate parameters for this algorithm. Those of you who use those systems should take in mind, or or if any of you develop it, should bear in mind that we should take into consideration the need of target computing. Many times those are very sophisticated ensembles that don't provide, that don't allow the right computational power. Explainable AI. One of the problems of AI models is that they are sort of closed box. They are black box solutions. In the area of safety critical systems, we cannot accept such a case. We need transparency. We need to be able to explain why the system reacted as it reacted. So this is another thing that we see as a real need in this area. Robust AI. We should be able to make sure that under no perturbation, the system just goes and causes death or severe injury. So we call it graceful degradation. We should make sure that the system works as expected. And finally, reinforcement learning is something that is becoming very popular now, and I believe that it will make a huge impact not only on gaming by companies like DeepMind of Google, but also in the area of decision making for the autonomous driving. So where do we go ahead? First of all, we believe that the right non-technical direction is cooperation, collaboration. There are various levels of collaboration that I'm talking about. First of all, between human and AI. If you think about autopilot or other defense systems that I mentioned, all of them, or most of them, are still having a human inside. So autopilot, we have sort of safety driver there that if something goes wrong, he can provide his assistance. If we think about space missions, we have ground control team which is capable to provide assistance. So we should be able to incorporate more human sense into AI systems, and I mean in real time. Another thing is the need of more collaboration between the robots. So we see more and more cases when information learned by one robot is instantly available to the rest of the fleet, and this is the right direction. At the end, I'm talking about technological partnerships. So business-to-business partnerships, I can mention that Renault and Nissan partnered with Waymo on driverless mobility. Also, we are right now at academies, so research institutes are the right place to cooperate with businesses to bring more value in order to, again, save lives in our case. And as we are in Israel, startup nation, so we are talking about more and more collaborations between the startups and the businesses. So bear with me, we're at the last slide now. So I'm from the Alliance. Alliance is the world's largest automotive manufacturer. And here in Israel, we are to bridge the gap between the startup nation and the Alliance. Those three companies, Renault, Nissan, Mitsubishi, those startups who have products available for proof of concept or any other ideas for collaboration are welcome. This is why we are here. And I hope that AI will help us prevent accidents from happening. Thank you very much. So actually, this is the exact case of what you saw. Those different levels provide such a solutions. We are talking about partial automation in different conditions. What the system of Nissan that I just showed is capable of hands-off driving only on highways. You won't be able to use it unless it's on a highway. So it's just, yeah, this is the idea exactly. Really? Okay. No idea. Maybe.
Thank you very much.
Thank you.